This conference will now be recorded.
See here. See. So in the previous class, we discussed about networking in Java. So in the networking in Java, we discussed about socket programming. So we can establish connection between two Java applications. So one is server application, another one is client application. Okay, so with the help of sockets, we are establishing communication between the server and client. We're establishing communication between two applications with the help of sockets. That programming is called socket programming. Okay, so this part we clearly discussed in the previous session. So with that, networking in Java chapter is over. So to apply basic networking, we can use this socket programming. Okay, now I want to start another chapter, new chapter. Just a minute. So chapter name is packages. So in today's session, I will explain about packages and inner classes. And tomorrow I will explain some features of Java. So tomorrow is the last class to you. Okay, in today's session, I explain about packages and inner classes. And in tomorrow's session, I will explain some features of Java. Okay, so say, listen, what is a package? What is a package? See, package means package is a folder. What is package? Package is a folder, or you can say this as a directory. What is package? Package is a folder, or you can say this as the directory. Okay, then what a folder contains, what a package contains? It contains it contains related classes and interfaces in it. It contains related classes and interfaces. So what is package? Package is a folder that stores related classes and interfaces. Package is a folder, okay, that contains related classes and interfaces. Okay, you already know some packages, or we have seen so many packages. Okay, you already know some packages. See here, for example, see, okay, see, you already know java.lang package. There is a default package for Java, java.lang package. Okay, java.util package, java.io package. Already we used these packages. See, just a minute. So this is, assume that this is a folder. This is a folder. Folder name is Java. Folder name is Java. In the Java folder, another folder is there. This is another folder. The Java folder, another folder is there. Okay, this folder name is lang. This folder name is lang. In the lang folder, some predefined classes are there, like string class, okay, string buffer class, okay, wrapper classes like integer class, wrapper classes like integer class, double class, okay, all the exception classes like arithmetic exception class. Okay, such type of classes and interfaces are provided in the lang package. So similarly, here another folder is there. This folder name is util. So all the utility related classes. So we have seen collection framework. In the collection framework, we used the classes like linked list class, uh, and array list, vector, okay, scanner class. Such type of classes are available in the util package. And also interfaces are there like list interface, queue interface, map interface. Okay, and like this, here IO package is there. IO package. In the IO package, data input stream, data output stream, data output stream, buffer reader. Okay, such type of classes and interfaces are there. Okay, so here Java is one folder. In the Java, this lang is there. This lang is the subfolder. Java is what? Java is a folder. So this folder I'm calling as package. Okay, this lang is the subfolder. This one I'm calling as the sub package. So in that package, what are there? Classes and interfaces are there. So these are the classes. These are the classes and interfaces. So like this, several classes are there, several interfaces are there. So these are the classes and interfaces in the package. So with this diagram, we can understand that what is package? Package is a folder, or you can say directory. So this Java is a package. In the package, sub package is the lang. So java.lang is the package. In the package, all the related classes and interfaces are there. Like this, several packages are there. So all the basic language fundamental related classes are available in the java.lang package. Okay, all the utility related classes and interfaces are placed in the java.util package. All input output related classes and interfaces are placed in the java.io package. All the network related classes and interfaces are placed in the net package. Okay, all the SQL related classes and interfaces are placed in the SQL package, like that. So related classes and interfaces are placed in the packages. So what is package? Package is a folder, or you can say it has a directory. Package is a folder. It contains what? Related classes and interfaces. Okay, then what are the advantages? What are the advantages with the packages? What are the advantages with the packages? See, listen carefully here. So the main advantages are with the packages, or first advantage is, see, first advantage is we can group related classes and interfaces. We can group related classes and interfaces. So all the language related classes and interfaces we are placing at one location. All the input output related classes and interfaces we are placing at one location. Okay, so like that, all the SQL related classes and interfaces we are placing at one location. All the network related classes and interfaces we are placing at one location. Like this, we are grouping the classes and interfaces. We are maintaining at one place. All the related classes and all the related interfaces we are maintaining at one place. So with this, maintenance become easier. Searching will become easier. Maintenance will become easier. So easily we can maintain all those classes and interfaces. So maintenance will become easier, and user can easily use those classes. Okay, so maintenance will become easier. This is another advantage. And another advantage is, uh, we can avoid naming conflicts. Means we can give same name. We can give same name for many classes which are placed in different packages. We can give same name. We can give same name for many classes or interfaces. We can give same name for many classes, but which are placed in different packages. Okay, those should be placed in different packages. Okay, now for example, see here. For example, uh, observe, just a minute. In the F drive, I'm creating one folder here. I'm creating a new folder. I'm creating one new folder. Okay, I'm giving folder name as package. I'm giving folder name as package. Okay, so in the package, I want to create another folder. Lang. Okay, so here I I want to create a file. For example, assume that I want to create a new text file. I want to create a new text file with the name uh, with the name math. With the name math, I want to create a new text file. So I'm creating here. Now I want to create another text file with the same name. Can I create here? Can I create another text file with the same name? No, we cannot. That is giving one message to us. See here. Do you want to rename new text document with math2? That is giving another name. Okay. So can you give same name for two files which are stored in the same location? No, we cannot. We cannot give like that. Okay. But for another class, I want to give the same name. I want to give same name for another class. I want to give same name for another class. I want to give same name math for another class. So for that, what I am doing is here I'm creating another folder here. Okay, for this I'm giving a name as util. I'm giving name as util. So I'm defining one math file in the lang package. I'm defining one math file in the lang package, and I'm defining one math file in the util package. Okay, so new text document, I'm giving name as math. So now same math file is available in the util folder, and same math file is available in the lang folder. Now see here, multiple files. For multiple files, I have given same name. So this is possible with the concept of this folder. If folder concept is not there, if you are placing all the classes here only, you cannot use same name for multiple classes. I want to create multiple classes with the same name math. So in the same location, you cannot define multiple classes with the same name. Okay, that's why I'm using this packages concept. So in the lang package, I'm creating math class like that. In the util package, I'm creating math class. In two different folders, I'm creating math file. Similarly, here also same thing. Here also same thing. Okay, so for example, there is a class. There is a class date class is there. This date is a class. This date class is available in java.util package. In java.util package, there is a date class, and the same date class is also available in the java.sql package. Okay, in the java.sql package, date class is there, and in the java.util package also same class date is there. So they use the same name. They use the same name, but this class is placed in two different locations. In the same location, you cannot use same name because class name should be unique. Okay, so like this, we can give same name for many classes, but those should be placed in the different packages. So this is possible with the help of this folder concept only, with the help of this package concept only. Without package, you cannot create like that. If folder concept is not there, you cannot create like that. Just now we have seen in our operating system also folder concept is there. In the same location, you cannot create another file with the name math. So what we did, we created two different folders. In one folder, we are creating math file. In another folder, we are creating another math file. So same concept here we are using. So they defined this class date in the java.util package, and they defined this class date in the java.sql package. If they define this class date again in the java.util, they cannot define like that. So class name should be unique. So that's why they defined in another package. So we can give same name for many classes. We can give same name for many classes which are placed in different packages. Okay, so naming conflicts will be avoided with the help of this packages concept. This is another advantage. And another advantage and most important advantage is reusability. Reusability. Okay, so the main advantage with this is reusability of classes and interfaces. So we are reusing the classes, the classes methods are there, we are reusing them. So this collection of packages is called library. Collection of packages, collection of packages, collection of packages is called what? Library. Java library. Okay, so what are the packages like java.util package, java.lang package, java.io package, java.net package, java.sql package? All these are packages. Such type of collection of packages I'm calling as Java library. See, from the beginning class to till now, we used this println method for so many times. We used this println method for so many times. They defined println method for one time, but we used this method for many times. Where it is placed, where to access this, what we are writing system.out. Println defined in the print stream class. So to access that, we are using object. So there is a static member. So that's why we are using system here, where this system is defined in the java.lang package. So java.lang.system.out.println is the package name. So in the Java directory, in the Java folder, in the lang folder, system class member is out. With the help of that, we are accessing println method. They defined this println method for how many times? One time. They defined this println method for one time in the class print stream. They defined in the class print stream. They defined for one time. Okay, they defined println method for one time, but we used this method for any number of times. So that is what reusability of members. Okay, so this is Java library. So just like in our colleges, library is there. In the library, books are there. In the library, books are there. Okay, those books are arranged in the racks. Books are arranged in the racks. So all the math related books are placed in the math rack. Okay, all the physics books are related. All the physics related books are placed in the physics rack. So why they are maintaining like this? Searching will become easier. So if I want to pick the math book, directly I go to the math rack and I pick the book. If I want to pick the physics book, okay, I go to the physics rack and I pick the physics book. So searching will become easier here. Maintenance will become easier here. So library has books. Okay, so today I'm referring one book. Today I'm referring one book. For example, this is CS rack. So this is CS rack. Okay, I'm referring one Java book. Today I'm referring one Java book. Okay, so if I want to refer that book after 1 month, I can refer that book. I can refer the same topic. After 1 year also, I can refer that book. So I'm reusing the book again and again. Book printed for one time, but I'm referring that book for any number of times. Reusability. So same concept they used here. So here Java library. Java library has packages. Java library has packages. Java library is a collection of packages. In the packages, okay, all the input output related classes and interfaces they placed at one place. All the language fundamental related, all the language related classes and interfaces they placed at one place. Okay, like in the college library, math books are placed in at one location, physics books are placed at one location. Similarly, in the Java library, they are maintaining like this java.lang package. Okay, so uh, java.net package like this. So Java library is the collection of packages. Okay, so here java.io is the package, java.lang is the package, java.net is the package. So in the packages, related classes and interfaces are there. So we can search for the classes very easily. Maintenance will become easier. Okay, and the main advantage is reusability. We can reuse the members which are in the packages. Reusability of members. This is the advantage here. So these are the advantages with the packages. I hope you understood. Okay, very clearly we discussed. So what is package? Package means it is nothing but folder. Okay, it contains all the related classes and interfaces. All the related classes and interfaces are placed at one location. Okay, so like Java is the folder. In the Java folder, lang folder is there. All language related classes and interfaces are placed in the lang folder. Okay, all the input output related classes and interfaces are placed in the IO folder. In the Java folder, in the IO folder, they place it this. So hence we can group the classes and interfaces with the help of packages. Maintenance will become easier, searching will become easier. We can use same name for many classes which are placed in different packages. We can use same name. Okay, and reusability of members. We can reuse these members which are in the classes. Okay, so these are the advantages with the packages. Now see about types of packages. Types of packages. So how many types of packages are there? Two types of packages are there. How many types are there? Two types are there. One is just now we discussed predefined, or you can say built-in. Predefined means already defined. Predefined packages. Next, user defined packages. Predefined packages and user defined packages. So predefined packages means they already defined some packages. They are defined by the Java developers. So Java developers define java.lang package. Java developers defined java.io package. Java developers defined java.sql package. Okay, so like this, these are what, these are the predefined packages. Java developers defined java.awt package. These are the predefined packages. Okay, so what are the user defined packages? So like them, like these predefined packages, or you can say built-in packages. Predefined means already defined. Built-in, already they built. So these packages are already defined by the Java developers. So like that, if we want to define our own packages, we can define our own packages in Java. We can define our own packages in Java. That concept is user defined packages. So if we want to define our own package, we have to use one keyword. That keyword is package. Package keyword. Package keyword. Package keyword is used to define the package keyword is used to define the package. Used to define the packages in Java. If you want to define the package in Java, okay, we use which keyword? Package keyword we use. So how many types of packages are there? Two types: predefined packages, user defined packages. So like they defined Java package, okay, like that I want to define my own package with the name pack1. This is a package name. So in the package I want to define another package. Okay, so like that, my Java dot my util, my Java dot my util. So this is the predefined. This is what user defined. In the my Java package, I'm defining another package, my util. So this is packages in packages. Okay, this is pack one is the package. So like this, we can define our own packages. So you can give any name. You can give any name as per your requirement. Okay. So now I want to define my own package now. I want to define my own package with the name of pack1. So package name is pack1. In the package, in the pack1, I want to create one class with the name class1. In the class1, I want to define a method with the name method1. Okay. So this class I want to place in one particular package, pack1. I already told package is a collection of classes and interfaces. So package contains dot class files, bytecode files. Package contains dot class files. I want to create dot class file of this class one, and I want to place that in the pack one. In the future, I want to reuse this class one. This is my task. Okay. So now we want to define what? We want to define a package with the name pack one. Means this is a folder. In this folder, I want to define one file with the name class one dot class. This bytecode file I want to create now. In the future, I can reuse this class in my program by writing the import statement. Okay, so this is my task. So to define the package, which keyword we have to use? The package keyword. Okay, now I'm defining, observe carefully. We want to define one package with the name pack1. In that, we want to define one class name is class1, and method name is method1. Remember one point. Okay, these classes should be public. These classes and interfaces defined in packages must be public. Then only we can consume them outside of the package. Otherwise, we cannot consume them. We cannot use them. So if you want to use a class outside of the package, if you want to use a class or if you want to use one interface outside of the package, then we must define them as a public. Then only we can use. Otherwise, we cannot use. Okay, so by default, scope is limited to within the package only. Within the package we can use, but outside of the package we cannot use. If you want to access outside of the package, we must define them as public. Okay, so now I'm defining. Listen carefully, observe carefully. Already you know it. Directly I'm typing the program. Uh, I want to create a package now. So I'm giving package name I'm giving as pack1. So in this I want to define a class. I'm defining this class as public class name I'm giving as class1 is the class name. So in this define public void method1, public void method1. Okay, starting point of method, ending point of method. Okay, now listen carefully. So here I'm writing one printing statement, system.out.println. This is method one of which class1. Okay, which is defined in which package, pack1. Okay, this statement I'm writing for our understanding purpose. I'm writing this printing statement. Now I want to create the package. Listen carefully. So we have written the program. After writing the program at command prompt, so we have to go to our program location in the F drive. Our program location is Java 7. There store the program. Okay, if you want to create the package, you have to write like this: Java C. Generally, we to compile the source file, we write like this: Java C. If the class name is class1, we write like this: class1.java. But now we want to create the package. We want to create the package. So to create the package, we have to use one option, that is -d. So we have to use one option. What is that one? -d. So -d. Here D stands for what? Directory. I already told. Package means what? That is a directory, or you can say folder. -d. Then where you want to create it, that path you can specify. So if you want to create the package in the current directory, write dot. Dot means what? Current directory. Dot means current directory. So in the current directory, so current directory is Java 7. So in the F drive, in the Java 7 folder, another folder will be created with the name pack1. In the pack1, that creates a class file, that is class1, class1.class. This class file will be created. This is the hierarchy. Okay. So generally we compile like this: Java C class1.java. So automatically in the current location, class1.class bytecode file will be created. But now we want to create the package. So to create the package, we have to write Java C -d. -d means directory. Where you want to create the package in the current location, so write dot. Current location is what? Java 7 folder. So in the Java 7 folder, pack1 will be created. In the pack1, this class1.class will be created. Now check here, observe here. In the Java 7, folder, there is no folder. There is no folder with the name pack1. There is no folder with the name pack1. Okay. There is no folder with the name pack1. So see, no images, two folders are there, but there is no folder with the name pack1. Now observe carefully here. Okay, I'm saving this program with the name class1. I'm saving this program with the name class1. Okay, class1 dot save, or rather, otherwise, I'm giving class name as class11. Save it with the name class11. Class11.java. Class11.java. Successfully saved. Where we saved it? In the F drive in the Java 7. Okay, now compile it. Use the command prompt. Okay, go to F drive, go to the program location. So generally to compile the program, we write Java C, we give the source code file name. like this. Okay, but we want to create the package now. So to create the package, we have to write what? -d java c -d, where we want to create the current directory. So d means directory. Directory will be created where? In the current directory, in the Java 7 folder. Okay, observe carefully here. So here first statement is what? Package p1, package pack1. So with this, the compiler understands that compiler has to create one package, one folder with the name pack1. So compiler creates it. So successfully package created. Now if you observe here, I'm refreshing here in the Java 7, I'm refreshing. Observe here, pack1 created. In the pack1, one class 11 is created. Okay, so in the Windows Explorer also you can check in the F drive, Java 7 folder, one new folder is created. One new folder is created with the name pack1. Just now it is created 16.9 737. Okay, in this bytecode file is there, class 11. So we defined our own package with the name pack1. In that one bytecode file is there, class 11. I want to use this in another program. I want to use this in another program. So now open. So what is our class name? Class 11. See, what is our class name? Class 11. Where it is created? In the pack1. In the pack1 package, class 11 is there. In that method 1 is there. I want to use that one. I want to use this method in the future. So for future purpose only we define this one, reusability. Okay, so open new file. Open new file. Okay, here I am giving this class name as pack demo. Pack demo. So here I want to consume. I want to use that method. Which method? Method 1. I want to consume method 1. So we have to create object for class 11. This class 11 is placed in which package? Pack1. So generally, if you want to use, see here, if you want to use system.out.println, what we are writing? System.out.println. System.out.println. Hello. Okay. I'm saving it with the name packdemo.java. I'm saving it. I'm compiling it. And I'm running it. So that is printing what? Hello. So if you want to use a class, in front of that, actually we have to write the package name java.lang. Like this we have to write. But this is a default package, so we didn't write it. So java.lang, Java, in the Java folder, in the lang folder, system class is there that we are using. So even if you write like this, that will not give any error. So here string is the class. If you want to use the string class, you can write like this, java.string. So that is implicitly that is taking. So like that, I want to use my own package. My own package name is what? Pack1. So pack1 dot, which class we want to use now? Pack1 dot class 11. Class 11. For the class 11, I want to create the package. I want to create the object. So pack1 dot class 11 obj equals to new pack1 dot class 11. Okay. So now object will be created. Now object will be created. With the help of that object, I want to call the method. What is the method name? Method name is what? Method 1. Method name is method 1. So call the method 1. So in the pack1 folder, class 11 class is there. For that class, we are creating the object here. With the help of that object, we are calling the method 1. Save this with the name pack demo. Successfully saved. Now compile it. Okay, Java C pack demo, Java C pack demo dot Java. Observe here, successfully compiled. I want to run this one. I want to run this one. See, there is printing what? Method 1 of class 1 defined in the pack1. We got the output. So I am reusing this method. So in any program you can use it. So instead of writing this class name, this package name each and every time here, each and every time we are writing class name here, pack1. So instead of writing here, you can write the import statement here. So write import. What is the package name? Pack1. pack1 dot, what is the class name? Class name is class double one. Now this class double one is ready to use. A compiler can search for this class double one. In which package? In the pack1. We are specifying the location of this class double one. Okay, I'm saving it. Now observe, now also it will give same output. I'm compiling the program again and I'm running the program again. Now also it is giving the same output. So hence we can reuse the members which are in the packages. Okay. Now listen carefully. I want to add one more class. I want to add one more class to the existing package. So in the package file, in one file, define one class only. Don't define multiple classes. That will give error. In one file, define one class or one interface only. Don't define multiple. That will give error. So now I want to create another class. I want to create another class, class double two. Okay, where we want to create it now? In the pack1. In the pack1. In the pack1. Okay. In the pack1, I want to create one class double two. In that, I want to define one method with the name method2. This is my task. So already pack1 existing package, to the existing package, I want to add the class now. Okay, so for that, again what we write is, okay, here we define the new class. So here write the package statement, package pack1. Okay, which class we want to define now? Class double two. Class double two. Okay, here define. So define this class as a public. Then only we can consume outside of the class. Okay, right? Public void method 2. Public void method 2. Starting point of method, ending point of method. Okay, I'm writing one printing statement, system.out.println. This is method 2 statement of which class? Class 22. Okay, defined in which package? Defined in pack1. Defined in pack1. This is a statement I'm writing. I want to save this one. So to save this, use this class name. Okay, class name is class double two. So save it. Class double two I'm giving. Okay, program saved. Okay, now I want to run. Observe carefully here. In the F drive, our folder is Java 7. So there we created one package. In the previous program, we created one package, pack1, that has how many class files? One class file is there. Now I want to add one more class file, class double two. So for that, just now we have written this code. Now compile it. So we want to create the package now. So to create the package, what we write? Java C -D. Okay, in the current location that package is there. So write dot. So if already package is not created, that creates a new package. Pack1 already created. So that opens that package. In that package, that stores this class double two dot Java. Okay, so this class bytecode file will be created in the package. Observe here. Okay, created, successfully created. Now check here. Check in the F drive, in the Java 7 folder, package name is pack1. In the pack1, another class file is created. So now how many classes are there in the package pack1? 2 classes are there. So like this, you can press any number of classes and any number of interfaces in the package. Okay, so this is the concept of defining the classes, defining the packages. Okay, now I want to use this one. So to use this, what I'm doing is I'm opening one new file. Okay, I'm giving this class name as package demo. Okay, so I'm writing the import statement. I want to use class 2 now. So write import, what's the package name? Pack1 dot, what's the class name? Class double two. For the class double two, create the package, create the object. So class double two obj equals to new class double two, new class double2. So with the help of object, I'm calling the method2. Okay, now save this one with the name uh, package demo. With the name package demo. With the name package demo.java. So successfully saved. Now compile it. Okay, Java C. What is the file name? Package demo. Package demo.java. So compiled, run it. So we are reusing the method2, which is in the class double2, which is in the package pack1. See here in the pack1 class double2's method2 called. So in the previous program we defined class double1, right? I want to use that one also. So what we write? Import pack1 dot class double1. In the class double1, for the class double1 I want to create the object. So write class double1 obj1 equals to new class double1. So already we defined. Okay, so with the help of obj1 I'm calling the method1. See here. So in the pack1 class double1 is there, class double2 is there. Those two classes I am using now in this program. I'm saving this, compile this program and run the program. See, this is method2 of class double2 defined in pack1. Method1 of class 1 defined in pack1. So hence you can reuse these classes for any number of times. So for reusability purpose, okay, for easy maintenance purpose, we are placing the classes in the packages. Hence we can create the packages. So this is pack1 is the user defined package now. Okay, now see, I want to talk one important point. How can we set the class path? Setting class path. How can we set the class path? How can we set the class path? Observe carefully here. So just now we have written this program. So this program is giving this output. I'm clearing this program. Once again I'm running. See, that is giving this output. So program successfully running. What I am doing is I am changing the location of our package. I'm changing the location of our package now. I'm changing the location of our package. Okay, so in the current directory it is there. So now it is working. Okay, so but I'm changing the location of the package. Okay, like this. See, I'm opening freshly. See here. So our package is in the E drive. Our package is in the E drive. Sorry, F drive. Our package is in the F drive. In the Java 7 folder, our package name is pack1. Pack1. So I'm cutting this one. I'm moving it to the E drive. I'm moving it to the E drive. So in the E drive, I'm pasting it. Okay, or otherwise I'm creating one new folder here. Okay, I'm giving this new folder name as package. In the package folder, I'm placing this pack1. Okay, so now where is our package now? In the E drive. In the E drive, in which folder? In the package folder, our pack1 package is available now. Okay, now check here. I'm compiling this program again. Now it will give error because that will not find the package. So it is giving the error. So that is giving error as package pack1 does not exist. So you are writing import statement in the program. Import pack1 class double2, pack1 dot class double1. But compiler is not finding where these classes are. Compiler is searching in the current directory only. In the current directory, this pack1 for package is not available. So that is not finding these classes. So in such type of situations, if the package is stored in some other locations, we have to set the class path. So how can we set the class path? So actually this class path is one environment variable like path. You already know how can we set the path. Path is the environment variable. To set the compiler path and to set the JVM path, we are using path. Like that, class path is used to specify the path of the class. where our classes are stored. If you want to specify that, we use class path environment variable. This is the environment variable of operating system. This is environment variable of operating system. So to specify the path of the class, we are using this command, class path. So what we write is just simply write set class path. So it's better to write that in the capital letters. Even if you write in the small letters, then also no problem. Class path. So set class path equals to, where is our class, where is our package now? We have to specify that one. Okay, we placed our package in the E drive. Okay, in which folder? In the package folder our package is available. So here we are specifying the path of our package. So please search for the package in the E drive, in the package folder. Okay, and our program file is stored in the current directory, so specify that one also, dot. Okay, after that specify, so if any previous class paths are there, they will be, so if you write this much command only, that sets the path, but previously if any class path settings are there, those will be gone. This new path settings will come, previous class path settings will be gone. I want to preserve previous class path settings also. So to preserve previous class settings also, we have to write percentage class path, percentage. So percentage class path percentage, why we are writing? To preserve previous class paths. So why we are writing this one? So to preserve, to maintain previous class path, to preserve previous class paths. Here dot means current directory. So please search for the classes in the E drive package in the current directory. That one we are specifying here. Okay, so now right here, it set the path, set class path equals to, okay, where is our package? In the E drive, in the package folder. Okay, and current directory. And to preserve the previous class paths, write percentage class path, percentage. Press enter key, that sets the class path. If you want to see the class path, you can use the command echo command. Echo percentage class path. Now observe here, that displays the class path to us. So this is the class path. So existing class paths are not available, that is not displaying. Okay. Now class paths. Okay. Now here we already set the class path. So just now we set the class path now. Okay. So now I want to compile the program again. Again I'm compiling the program. Observe now that knows the class path. Again I'm compiling the program. So before class path that was giving the error. Now it knows the class path. Okay, I'm running this program. Okay, so compile the program again. Now it is successfully compiling because it knows the class path. I'm running the program. Okay, see, it is displaying the messages. So hence we can set the class path. So to set the class path, we are using the environment variable class path. So write the command set class path equals to, specify the location of the package. The E drive in the package folder, our package is there. In the current directory, our program is there. So we must write this dot also. So to preserve the previous paths, we are writing this one. That's it. Hence we can set the class path. So this is about setting class path. Okay. So now my task is, I want to defining packages in packages. Now see the topic, packages in packages. Now you know how can we define the package? How can we use that one? So now I want to define a package instead of another package. I want to define my own package, my Java. Okay, and I want to define my own package, my util. This package I want to create in the current directory. In the current directory I want to create. So in the my util package, I want to define my own class name, is my math. Class name is my math. My math. In that, I want to define one method, add method. This is my task. Okay. So now what is our task? We want to define the package in another package. So defining package in another package. So topic name is packages in packages. So defining sub package in the package. So my Java is what? My Java is a package. My Java is a package. In the my Java package, I want to create my util sub package. So they defined the Java package. In the Java package, they defined util package. Like that, I want to define my Java, my util packages. Okay, they defined math class. Like that, I want to define my own class, my math. Okay, so this is a class name. Okay, this add is what? Add is a method. This is our task. This is our task. So to do this, okay, directly I'm writing the program. Observe carefully here. I'm opening new Java file. So define the package now. So whenever we are defining the package, we write like this: package. Then specify the package name. Package name is what? My Java. Dot. Specify the sub package name. My util. This one we write. So what we write? We specify the package name. Package. Package. Package name. Package name. Dot. Sub package name. So like this, we can define any number of sub packages. In the sub package, if you want to define another sub package, write dot sub package name. This statement we have to write. This syntax we have to follow to define the package in another package. Okay. So in our example, what we are writing: package my Java dot my util. So when the program gets executed, first that creates my Java folder. In the my Java folder, that creates my util folder. In that places our the class. Class name is what? My math. So this my math class file will be created in the my Java my util folder. In the my Java folder, my util folder will be created. In the my util folder, this my math class file will be stored. Observe here. So I am giving this a package statement. Then right, I'm giving class name as my math. In this, I'm defining one method. I'm defining the method. I'm defining method as public void, or method name I'm giving as add. Method name add. I want to pass two values. One is x and another one is y. Okay. Uh, I want to return the value. I want to return the value. I want to return the some value. So write return x plus y. Define this class as public. Define this class as public and define the method as public. Okay. Now save it. Okay. So I'm saving this with the name my math. I'm saving this with the name my math dot java. Okay. So successfully it is created. Observe carefully. Now we want to create the package. So what we write? Java C -d. If you want to create it in the C drive, you can write like this: C drive. In the C drive, in the package folder, if you want to create, you can write like this. But I want to create in the current directory. So -d, I'm writing dot. So the current directory, it will be created. So give the file name. What is the file name? File name is mymath.java. Mymath.java. So Java C -d dot mymath.java. Compile it. Okay. Observe carefully here. In the F drive, in our folder Java 7, now one package is created. That package name is my Java. In the my Java package, my util package is created. In the my util package, my math dot class file is created. Okay. As per our requirement, that created what? My Java package. In the my Java package, that created my util package. In the my util package, my math class file created. Okay. So now I want to use this one. So already it is created. Okay, I want to use this one. So to use this, open new file. Here write the import statement. Write import statement where it is in the my Java package, in the my util package. What is the class name? Class name is my math. That one I want to use here. So now create object for my math class. My math obj equals to new my math. So this my math class has add method. So to call that add method, obj.add, obj.add of, I'm giving first value as 20, second value as 30. That returns integer value. That integer value I'm capturing in the variable x. That x value is the sum value. I want to print that one. So write system.out.println sum equals to concatenation operator x. Okay, so just now we created my Java package. In that my Java package, we created sub package my util. In that my math class file is available. So that class, for that class, we are creating the object here. With the help of object, we are calling the add method. I'm saving this one. Okay, give the class name here. I'm giving this class name as the uh, package demo one. Package demo one. Save save it with the name package demo one. Package demo one dot Java. Okay, now I'm compiling this program Java C. Package demo one. Package demo one dot Java. Java C package demo one dot Java. Okay, successfully compiled. Run it. Java package demo. Sorry, package demo one. Package demo one. Sorry, package demo means previous program output that is giving. Okay, sum equals to 50. See here, we got the answer. So in the my Java package, so in the Java 7 folder, my Java folder is there. In the my Java folder, my util folder is there. There my math class is there. That my math class. For that my math class, we are creating the object here. That my math class has add method. That add method we are calling, that is executing the code. That is giving the output to us. Hence we can create the packages in packages. Okay. So you can define the interfaces also. Remember one point. Okay, I'm not defining interface. You can try it. Okay, because time is not there. Okay, you can define, if you want to define the interface in a package. So like package p1, p1 is the package name. If you want to define the interface, define interface i1. Okay, in this define the abstract method. Okay, define this interface as public. Define this interface as public. Okay, here write public void m1. So this m1 is the abstract method in the interface. So define this one in one file. Define this in one file. So for this interface, I want to define the implementation class. So that implementation class should be defined in the same package. In the same package, I'm defining the implementation class. So class, I'm giving class name as C1 implements. C1 implements which package? I1 package. So define this one in one file. Define this one in another file. In one file, define one interface or one class. You cannot define multiple. You cannot define this implementation class here, because in one file you can define one interface or one class. You cannot define multiple interfaces or multiple classes. So define it in one class, one file, define it in another file. But these two will be stored in the package p1 only, because here you are specifying. Okay, then you can reuse that one. Okay, so this is about packages. So packages concept is over. So what is package? Okay, you can try it. You can try it. So try it in one file. Okay, save it with the name i1 demo, i1.java. Save it with the name c1.java class name. Save it with the name i1.java. So like this, define, you can try it. Okay, define this in one file, define this in another file. Here provide implementation part for the m1. Okay, now finally in another file, use this class. Okay, So what is package? Package is nothing but folder or directory. Here Java is the directory, Java is the folder. In the Java folder, lang is subfolder. In the subfolder, all the related classes and interfaces are available. So package is the directory or folder. It contains related classes and interfaces. What are the advantages here? We can group related classes and interfaces, and we can maintain them very easily, and we can give same name for multiple classes which are stored in different packages. For example, class date is available in the java.util package as well as in the java.sql package. Okay, so the main advantage is reusability. We are reusing those classes, and the classes members are there, those members we are reusing. So reusability is the main advantage with the packages. So we can create the package, we can create the package in another package, we can create within the same directory, we can create in another directory, we can set class paths if the package is in another location. So this is about packages. Packages chapter is over. So next topic is inner classes. Listen carefully. Inner classes. I will finish class at 8:20 because after 8:20 another session is there. Uh, uh, on this link. On this link. Okay, not for me, for another faculty. Okay. So see here, inner classes. Inner classes. Inner classes means defining a class in another class. Defining a class in another class. Defining a class in another class is called inner class. Defining a class in another class is called inner class. So instead of the class, we can define another class. So there are four types in the inner classes. So in the inner classes, see, first one is member inner class. First one is member inner class. So inner classes can be also called as nested classes. Writing class in another class is called nested class, or writing class in another class is called inner class. So member inner classes, member inner classes. Okay, next one is static inner classes. Static inner classes. Okay, so next one is local inner classes. Local inner classes. Okay, and next one is anonymous inner classes. Anonymous inner classes. Anonymous inner classes. So among these, first one is what? Member inner classes. So member inner classes means, see, within the class we can define another class. So first I will explain it. After that I will explain the advantage. So class, I want to define a class with the name outer. So this is the outer class. In the outer class, I want to define another class, inner class. So this is inner class. So instead of the class, we are defining another class. So this concept is called what? Member inner class. Okay. So in a class, we are defining another class. See, for example, here I'm opening a new Java file. Okay. Observe carefully here. Here I'm defining one class with the name outer. With the name outer. So here I'm defining one method. Method name is m1. So this is outer class method. I'm writing one printing statement here. System.out.println. System.out.println. This is m1 method of outer class. M1 method of outer class. Okay, I want to define another method m2, but in another class I want to define. So instead of the class, I'm defining another class. So this is what? This is inner class. In the inner class, I want to define the method. So I'm copying it and I'm pasting here. Okay. So this is what? This is method 2. Modify it. Method 2. This is m2 method. This is m2 method of inner class. M2 method of inner class. Okay. Now observe carefully here. Observe carefully here. I'm giving this class name as inner demo. I'm giving class name as inner demo. Observe carefully here. I want to create object for outer class. I want to create object for outer class. Outer obj1 equals to a new outer. So with the help of obj1, I'm calling m1. Can we call like this? Yes, we can call, because m1 is the member of outer class. So we can call it with the help of object. I'm saving this one with the name inner demo. I'm saving this one with the name inner demo, inner demo.java. Okay, so successfully saved. I'm compiling it and I'm running it. See, that is displaying m1 method of outer, m1 method of outer. So now with the help of this object, listen carefully here, I'm calling m2. Can we call m2 now? No, we cannot, because this m2 is not member of outer class. This m2 is the member of inner class. Okay, so this m2 is the member of inner class. So you cannot access m2 with the outer class object. Observe here, save it, it will give error now. Compile it, that is giving the error. Okay, cannot find the symbol m2. So that is not finding where this m2. Okay, so if you want to access this inner class member, okay, so if you create inner class object, for example, I'm creating inner class object here. So inner obj2 equals to new inner. Now what happens? Observe here. Now also it is giving the error. So because that is not finding where is this inner. So if you want to create the object for inner class, okay, we have to use this outer class name. We have to use outer class name, outer dot inner. Here create the object, create the object. So whenever we are creating the object, if you write like this, now also it will give error. Now also it will give error. Observe. Okay, so we have to use the outer class object name. We have to use the outer class object name. So outer class object name is what? Obj1. So hence you can create the object. Okay, now observe carefully here. I'm saving this one, I'm compiling it. Just a minute. Yeah, sorry, obj2, right? With the help of obj2 we have to call. With the help of obj2 we have to call. Okay, I'm saving it, compile it and run it. See, that is giving the output. So here whenever we are creating the object, so what is happening internally here is, here internally two classes will be created. Here if you write class in another class, okay, so internally it creates how many classes now? Internally it creates two classes. Just a minute. So here internally how many classes will be created? Two classes will be created. Okay, so one is class outer, this will be created, and another class is created by, another class will be created by the compiler gives the name here. So that gives name like outer dollar inner, that gives name like outer dollar inner. So like this, that gives one name and that creates the inner class here. So compiler is creating two classes, but we are defining a class instead of another class. Okay, and whenever we are creating the object like this, whenever we are creating the object like this, so when we are creating the object obj2, so this obj2 will be created inside of the obj1. So in the outer class object obj1, this inner class object obj2 is creating. Okay, so here the advantage is sometimes we need to provide security for the class. Sometimes we need to provide security for the class. If you want to provide security for the class, we can use private modifier. So this you cannot apply private modifier directly for the class, but for the inner class you can apply private modifier. Okay, for the class you cannot apply directly static keyword. For the inner class you can apply static keyword. That is the advantage here. Okay, and this inner class, so generally if the class has private members, if the class has private members, if the class has private members, this private member is not accessible outside of the class, but this private member can be used by this inner class. Inner class can access private members. So the main advantages with the inner classes is, one is provide security for the class. Okay, use it to provide security for class. So to provide uh, to provide security for class. And another advantage is, so for the inner class we can apply private, so hence we can provide security for the class. And another advantage is we can access private members. We can access private members. We can access private members in inner class. We can access private members in inner class. So instead of the inner class we can access private members. So these are the main advantages with the inner classes. So by default we cannot define a class as private. We cannot define a class as private. So can we define like this? Can we define private class like this? No, we cannot. Okay, but we can define a private class instead of another class. So this inner class can be defined as private, or inner class can be defined as private class. C1. This inner class can be defined as private. This inner class can be defined as static. There is the advantage here. So to access only static members of the outer class, we define this as the static. It can access only static members. It cannot access non-static members. So to access static members or non-static members, define simply class, or you can define private also. Okay, so hence we can provide security for the class. Okay, and we can access private members of the class in the inner class. These are the advantages. Okay, now I'm stopping the session. Okay, yes, tomorrow is the last class. Inner classes topic is over. Okay, so tomorrow is the last class. Tomorrow I will explain some features of Java. Tomorrow is the last class. Okay, yes, any doubts regarding today's session?